This unit is on dividing real numbers. We'll talk a little bit about irrationals later. So how do we divide real numbers? Well, it's pretty easy. When we took subtraction of real numbers, we just turned it into addition, since we already know how to handle addition. We're going to do the same thing with dividing. First things first, always turn the second part that you're dividing into a fraction, and then very simply, instead of dividing, change the division to a multiplication sign and flip the fraction upside down. That is it. Don't mess with the improper fraction. Don't have to turn it into a mixed number. None of that. So again, first part stays alone. Division becomes a multiplication. Second part flips upside down. If you want to see the fraction there, so you know you're multiplying across the top and the bottom. That's it. So to divide, we should multiply by what we call the reciprocal. And the one exception is that we cannot divide by 0. So as long as that number isn't 0, we're pretty much good to go. In case you're wondering what will happen when you try and divide by 0, I recommend you try it in your calculator. See what happens. So just take any old number, 4, 5, 20, whatever, and go forward, divided by 0. See what happens. So here's some practice. 16 divided by -4. 16 times 4 over -1 equals 64 over -1, which is just -64. -64 divided by -4. -64 times 1 over -4. And this cancels to 1, and this cancels to 16. The negatives cancel each other, and you get 16. -3/8 divided by 3/10 is -3 over 8 times 10 over 3. Cancel the 3 and the -3, get -1. Cancel 5 2s and 10, 4 2s and 8. Multiply across, we get -5 over 4. Notice we always like to put the negative on top. So we never write we never write 5 over -4. We always write -5 over 4. -2/5 times 1 over 18. There's 9 2's here. There's -1 2's here. Get -1 over 45. That is it. What about a problem like 1/3 divided over 2/3? And I've given it away a bit there. Well, whenever you see a fraction, you can always write that as a divided sign. So it's the same as saying 1/3 divided by 2/3. We know how to handle that. That's the same as 1/3 times 3 over 2. 3's cancel. We get 1/2. Now, something that pops up a lot. What's the difference between 1/2 times 2x minus 4 and 2x minus 4 over 2? The answer is no difference. It's the exact same thing. So feel free to go back and forth. If you have 1/3 times 6x plus 9, you could just write it as 6x plus 9 over 3, which is 6x over 3 plus 9 over 3. And get a lot of canceling here. Be the same as 2x plus 3. So don't be shy about changing those back and forth, whatever you're comfortable with. And here's an application. How do we find the mean of something? Well, division. Well, if we have a set number of scores, in this case we'll say 4 of them. People got a 19 out of 20 on a test, 17 out of 20, 16 out of 20, 14 out of 20, 15 out of 20, and a 20 out of 20. And I would say what's the average, which is what mean really means. Well, you just add them all up. Divide by however many of them are. There are 1, 2, 3, 4, 5, 6 of them. And in this case, I'm going to use a calculator that I have off to the side. Divide it all by 6, and I get 16.8. So the average score on that quiz was a 16.8 out of 20. Good or bad, it's good to know so you can make adjustments. Yes, the students know what they're doing, move on, or no, they don't. Go back and practice some more. Now, how do we find square roots? How do we compare certain real numbers? Well, what's a square root? Well, this is a square root. We'll put 9 in there, and this is called the radicand. This is called the radical. Do not get hung up on them. Most math teachers don't use them, but on occasion you'll see radicand. A radical usually refers to the whole thing. So, what is the square root of 9? Square root of 9 equals 3. When you are told to just take a square root, it is always positive. And the reason I bring that up is you might have known that -3 times -3 will equal 9. So how come the square root of 9 is not -3? Well, when we have a square root, we say it's always positive. However, if we introduce a square root into a problem, and this is confusing, then we can look at the positive and negative. So square root of 9 equals 3. By writing a square root of 9 right here, we're saying, give me the positive answer. By solving x squared equals 9, well, to do that, we take the square root of both sides. Now, we put the square root into the problem. So then we have to say it's plus or minus 3. We'll get lots of practice on that. It all depends on how the problem is set up, but it's just something to be aware of for the time being. So how do we approximate root 5? Well, 2 squared equals 4, and 3 squared equals 9, and 5 is in between them, so 5 is pretty close to 2 squared. I'm going to guess the square root of 5 is probably about 2.2, but the better way to do it is just put in your calculator. Square root of 5 equals 2.24. So I did a pretty good job guessing, but it was just that, a guess. So now we can start putting all these in order. Got to change them into decimals. 4/3 is 1.333, repeating. Negative root 5, well, we just did that. That's negative 2.24. Square root of 13, I'm going to have to put in my calculator. That's 3.61. Negative 2.5 is already set. Square root of 9 we know is 3. So if we're going to put them in order, we have to go from smallest to highest. And we're going to have to use the negatives first. In this case, it's negative 2.5. And then it's negative square root of 5. Even though we know it's negative 2.24, we write it as the original number. Then the next biggest one is 4/3. And the next biggest one is square root of 9. And then finally, square root of 13. So we've converted them all to an approximate decimal, and that way we can say which one's the biggest and which one's the smallest. Now that you know what a square root is, we can actually define real numbers. So we started with natural, and that was 1, 2, 3. We put that in a small box. Then we added 0, and that gave us the whole numbers. And put that in a slightly bigger box. Then we added the negative numbers, and I'll just put it in, I'll write this out. Negative numbers. And these were called the integers. And we put a ever increasingly bigger size box on there. And then we put in fractions, which, as we quickly found out, can be written as decimals. Called that the rational numbers. We put a bigger box around that. And then we finally get real numbers. Real numbers are all of those plus irrational numbers. Things like the square root of 5, which goes on forever and ever and never ends, never repeats. Things like pi, e. These are all special numbers you'll learn more about later. And those are all the real numbers. You might ask yourself, well, what do I care about? Which numbers are which? It doesn't seem to make a difference. That's true, but you have to be very careful because later on there's actually something called imaginary numbers, which makes life even more confusing. Sometimes it helps us solve problems knowing which set of numbers we're working in. That's it. Good luck.